Hello, this video is to present the new release of Reqpy. Main change is that now you can pip install Reqpy, but there have been also some changes on the workflow. So I'm going to present here example 3 again. The examples are the same that for the first release, but they were accommodated to the new workflow. So just as before, you have to start by importing the functions that you're going to use. In this case, we're going to perform a matching of a target RotDnn spectrum. So this is the function that will perform that task. And all of these other functions are helper functions that will help us to load the cite records, to plot the results, and to save the results. Okay. So just as before, you have to specify the files where your cite records, both components of your cite record are, and the target spectrum, the damping ratio for that target spectrum, and the periods between which you want to perform the matching. So let's move to what actually changed. So here I'm calling the function Reqpy RotDnn, and we specify the two components we want to use as seeds, the sampling frequency, and so on. So I'm gonna start running this, and what you will see that is different is that this function now will return a dictionary. Let's wait for this to finish. Okay, so now that the iterations are complete, let's see what we got as a return for this function. We go to results. We see that it's a dictionary with 13 elements. From here, you can access the time histories of displacement, velocity, and acceleration for the spectral image record, both components of the spectral image record. You can also access the response spectrum, in this case the RotDnn spectrum for the spectral image record and the original records, and some other stuff that can be useful. So to plot the results, now you have independent functions to help with that. So we're calling here the plot RotDnn results function. That this was the function that generated let's see, these two plots, the time history plot and the spectra plots. So you can see that the return for that function is 2 figures. So you can then save those figures as a figure if you want, or just show the figures. If you want to save the results, you have new function helpers. If you want to save the results in the same format that peer nga, you will use this function, save results as 82. If you want to save the results as one column only with the accelerations, you use this function. And I'm not doing it here, but also if you want to save the results as 2 columns, time and acceleration, then the name of the function is like this, but with a 2. Now, if we go to the folder where we are running the code, we will see the files that were generated. For example, here we have the first component in 82 format. Let's open it. And we'll see this will be component 1 of the spectral image record in the peer nga format. We did also save it as one column. Let's open the one column version. In this version, you only have one column of accelerations. And you will also get, well, if you save it, the figures with the response spectra and the time histories. So I think that pretty much summarizes the changes. All of the 4 original examples were adapted to the new workflow. You can check those. The previous videos go in more detail over these examples. I do think the new workflow is more adaptable, especially if you are generating a bunch of records. So I hope it helps. And if you have any questions or recommendations, just drop me a line.